All right, advanced algebra, topic 7, section 7. I believe this is the last section in this topic, so we are gearing up for a test. And what they're doing in this last section is they're going to throw all kinds of factoring at us, okay? So the first, and I've already talked to you about this, is what we call a perfect square trinomial. And the reason it's called a perfect squared trinomial is when I factor it, I get a binomial squared, okay? So we can still throw these things in our factor puzzle. X squared, 14x goes here, 49 goes here. And I really don't have a lot of choices with 49. It's either 1 and 49 or 7 and 7. Obviously, it's going to be 7 times 7. Multiply across, and everything works, right? So our answer is the quantity x plus 7 times the quantity x plus 7. Or we could say x plus 7 quantity squared. And you'll have to read the directions in your online homework and make sure you're putting the answer the way they want you to put the answer. You know, if you put this, they may count it wrong. I don't know. So you'll have to work with that. Example number 2 over here. The 9x squared would go here. 25 minus 30x. And, you know, pretty much it's going to be the perfect squares. So 3x and 3x, 5 and 5, make 15x and 15x. But it looks like in order for this to work, they both need to be negative. And then I check it. That's 9x squared, that's 25, and that's that. So the quantity 3x minus 5 times the quantity 3x minus 5. And again, read the directions as you answer these questions and see how they want you to express your answer. You put this and you get it wrong because they wanted this. Okay. We already talked about this as well when we went over multiplying conjugates. So when we go through our factor checklist, we say, number 1, is there a greatest common factor? And if so, we factor it out, right? Second question, is it a binomial? And there's actually 3 cases of a binomial. It could be the difference of 2 squares. It cannot be the sum of 2 squares. The sum of 2 squares does not factor. It could be the difference of 2 squares. It could be the difference of 2 cubes. Or it could be the sum of 2 cubes. Those are the only 3 that I can factor. And then, of course, our next question, is it a trinomial? Okay. So if it is a binomial, I don't need to go to a factor puzzle. I just need to put my 2 sets of parentheses. And then take the square root. The square root of 4x squared is 2x times 2x. The square root of 81 is 9 times 9. And then, as I said, in order for the middle term to drop out, these have to be conjugates. So one of them is positive, the other one is negative. That's what makes them conjugates. And that's all there is to factoring the difference of 2 squares. I don't believe in our book we get to the other 2 cases, but they do exist, and you will definitely get to them as you progress in mathematics. So, is there a greatest common factor? Nah. It's a binomial. Difference of 2 squares, the square root of 9x squared, 3x, and 3x. The square root of 100, 10 times 10. One of them positive, one of them negative. And that's it. It's factored. And then, as I said, you know, that we also have to know how to take out the greatest common factor. But then we also have to ask, after I take out the greatest common factor, can that thing still be factored? Okay, so when I look at number 5 here, I can take out a 3xy, and I'm going to be left with x squared minus 4y squared. Well, that's still factors. That's the difference of two squares. So I put my two sets of parentheses. X squared is x and x. 4y squared is 2y and 2y plus minus. Now it's fully factored. When I look at the next one, greatest common factor would be 4x, which leaves me with x squared plus 6x plus 9. And let's check that trinomial. I bet it factors. It looks like a perfect squared trinomial, which it is. It's x plus 3 times x plus 3. So we can write 4x times the quantity x plus 3 squared. And then this last one looks like I can take out a 2. And if I take out a 2, I have 25x squared minus 16y squared, which is then the difference of two squares. So I put my two sets of parentheses. The square root of 25x squared is 5x and 5x. The square root of 16y squared is 4y and 4y plus minus. And there you go. Last example. It's kind of lengthy. She needs two cylindrical containers to package her voice-activated speakers. A packaging company makes two different cylindrical containers. Both are 3 inches high. This is 3 inches high. The volume of one cylinder is 3 pi x squared cubic inches. And the volume of the other is pi times 3x squared plus 30x plus 75 cubic inches. Determine the radius of each cylinder. How much greater is the radius of one container versus the other? So our other container is the same height, but it's not necessarily the same same width, same radius, but the height is 3. The volume of the cylinder they give us here is pi r squared h. So what we can do is set 3 pi x squared equal to pi r squared times the height, which is 3. And then we can solve that for r. So it looks like if I divide this side by 3, I get pi x squared equals pi r squared, and then I can divide both sides by pi, and I get x squared equals r squared. Okay. Then over here, I can say that pi r squared h equals 3 pi, and that 3 comes from the height. I'm plugging that in. And then 3x squared plus 30x plus 75. Again, I should have plugged in 3 over here for h. Sorry. Again, I can divide both sides by 3 pi, right? And the 3 pi's drop out, and I get that r squared is 3x squared plus 30x plus 75. And I can actually take a greatest common factor out of there. I can take out a 3. And I get x squared plus 10x plus 25. And then that thing factors. We go to our factor puzzle, x squared. X squared is x times x, 5 times 5. So we have r equals 3 times x plus 5, sorry, r squared, quantity squared. And so basically, you know, obviously this one has the bigger radius than this one. It says how much. I'm not interested in that unless they were to give us a value to figure that out. So it's just obvious that one radius is quite a bit larger than the other radius. Okay, that's sufficient for me. Okay, that is